Welcome back to ABAGY Robotic Welding. We're posting regularly, so please subscribe so you don't miss a video.
Yes, Richard Breffney, you are right. Don't miss a video. Subscribe, leave your comments, engage with us. Anything that looks exciting or curious to you, put it in the chat. We would love to have a conversation with you, and we would love to see you at Fabtech November 8th through the 10th. 30 minutes north of Chicago is a magical place, Wheeling. In that magical place, the ABAGY Demo Laboratory. I am here to get a sneak peek behind the scenes of the exciting manufacturing and technology going on here. And guess what? You're coming with me. Come on, let's go. So here we are inside the very exciting, super secret ABAGY Demo Laboratory. So many amazing pieces of innovation and manufacturing all around us. How long have you been with ABAGY and what is your role?
Yeah, I've worked for ABAGY for about 5 years. I'm an engineer, and actually my major area of expertise is motion planning. I know a lot about why the robot moves a certain way, why it do this and don't do that. So,
amazing. Should we go meet some of your coworkers, your robot coworkers?
Sure, we can do that.
So, Tim, tell me, why are demo sites like this one so important to ABAGY?
Well, it's one thing when you see certain experiences virtually, but when it comes over and can play with that, it makes a lot of difference for our customers. So that's why we have this location and few others. The one would be in Kansas and the second one in Bay Area, California.
So I know you're preparing for Fabtech, which is one of the largest manufacturing gatherings, and something really exciting that you are doing is you're going to do real live welding. So I don't know if all of these demo parts are going to fit in your carry-on, but tell me, why do we have all of these? Tell us more about these.
Well, we do have two different kinds of parts. The one on the bottom, they're more like perpendicular types, straight weld. This one dedicated to cover circle welds. And that's how we end up building those one for the demonstration. It doesn't mean that's the only part we can do. We can do any kind of part you like. It's just the one you will see on the Fabtech and in this area. Can you tell me a little bit more about yourself? What's your role? What's your idea?
So I'm Luke Faulkner. I work at the American Institute of Steel Construction. I am Director of Technology Integration. So what that means is wherever technology kind of touches the structural steel supply chain, that's where we might have an initiative or where I might come in. So that can involve, that's involved anything over the years from BIM, 3D modeling, standards to support that, all the way to AI, AR projects, welding technology projects. It's really morphed in the last few years.
Okay, yeah, that sounds about close to what we do. We do a lot of welding applications, and basically we weld almost anything you can imagine. So we have a match in this regard. Okay. Yeah, if you don't mind, we can come closer to two robotic cells we've got, and I will tell you a little bit more what we have. Okay. So right now there are two robotic cells, the one with the Kawasaki robot and the Miller welding source. There's nothing else. There's just a welding table in front of it, and that's it. Yeah. The other robotic cells is with Fanuc and Lincoln welding source, but it also has a 2 degrees of freedom positioner with this table on it. Okay. You can notice that there is one more object on top of the regular welding cell setup is this black box.
Right.
The black box right next to the welding torch. The one on this robot and the other one on that one. That's the 3D camera we have installed on it. And we use it to make those robotic cells smarter. They now are able to see what is going on and how it works. We have a 3D model of a part.
Is it a generic step file? Is it IFC? Is it?
It's just a step one.
Just a step.
It has been uploaded to our system. Then it was additionally analyzed to extract this geometry data, as I mentioned, all those welds. And after that, all the programming you need is as simple as that. You just do one single click. So, as you may notice, there's now 0 points.
Right.
I placed it on purpose somehow, so there's no way I can somehow figure out the same position as I was doing on the previous runs. It's brand new. I can always place it any way I want it to. Okay, we can define the task for the robot. What you need to is to send this task to the production. So let's start with that. What will happen after that? The machine will scan the working zone. So that will be the first part, and you will see what will happen. So basically the camera is standing there statically, but positioner moves.
Okay. The first question I had is about the scalability of it. Obviously, I mean, in a structural shop, you're going to deal with 60-foot long, 60-foot long beams, if not more sometimes. And
that's for us. That's what we started with.
Okay.
We've gained our most of the experience with the long structures, like 60-foot beams, and we were able to weld them in the same manner as you're seeing right here. It just basically we went from the bigger one to the smaller one.
So I mean, like in that case, you'd be moving the robot. I would guess like you'd be moving it on a track.
And there will be one more difference. In this case, the camera is small like that, but it takes a while to capture all the data. With the bigger cells, the camera is much bigger.
Right.
And with one shot, it can cover like 6 feet. Square area, and that would be the only difference. But the software, the technology is the same.
Okay.
For us, it doesn't really matter the size of the part, so we can deal with that. Moreover, on those bigger cells, you can place a number of small parts inside. And right here, you can see what the machine sees. So those are our clamps.
Those are your clamps.
Yeah, you can see that. So basically, we are facing them like this. Right now he'll perform touch sensing, but after that there will be welding. So I don't want you to be hurt. So please wear your mask. So right now there's an additional procedure that's a touch sensing. This way we can guarantee the wire is exactly in the same spot. Yeah, we can come over this side. Right now the task is finished.
Take a look.
So we can approach it. And that's what we've got.
Oh yeah.
That's our user interface. What we start with. That's the weld we have selected. Automatically, based on the geometry, we identify type of a joint.
Okay.
So right here it says, it's a fillet weld T-joint with no gap. By default, for this type of weld, we identify a set of welding procedures. For this one, by default, was selected PA welding position, which refers to 1F in American standard.
Right.
So there is a set of welding parameters, you can adjust that. So the first one, the speed, how fast it goes. And two major welding angles. So the one would be the work angle. You can adjust it, you see it moves.
Right.
And the travel angle. So in this regard, I will just slightly shift it over here. You see it moves.
I saw.
And the only reason why we were able to get all the way through, even though the nose was supposed to be colliding with, we gave it some flexibility, tolerance. Yeah, the travel angle tolerance.
Oh, I see. Yeah.
If it within this tolerances, it will perform those welds with no question asked.
If you had an oddball piece that didn't allow you to get into like to 1F to ideal position, can it weld out of position?
Sure.
Can it default to a second position or?
Yeah, I will show you that. So right now I have here only predefined one welding position, it's PA. Let's say I want to do PB.
Yeah.
PC or others. You can select I want a PA, then PB. If you cannot do PA,
then you can say I want to do it vertical or I want to do
That's the way you just tell the system what is your preferences. Let's say in structural steel, especially in big beams, you can do multi-pass welds. So what it takes to define a new multi-pass is as simple as just doing like this. Because after that, if you need to, you can just utilize the offsets on the walls. Let's say I want to do like this. And most of the time, 2 is not enough. You would rather add the third one. Okay, we're fine with that. So that's how you add it. 2 more layers.
Yeah.
Everything else remains the same. And the first one, the second one, and the third one. Moreover, let's say you want to do weavings. No problem with that. Just one click. You edit your weavings and a set of different parameters with amplitude and all the other stuff. Plus the type of weavings, and we've got a support of 2 types of weavings. The one which supported by the specific robot brand. So we just send them 2 points.
Which is this the Fanuc?
That's the Fanuc, yeah. And they will generate the trajectory. So we'll just send them 2 points and they will do the weaves. But let's say you have a brand of robot which doesn't have specific weave type. In this regard, you can just click that and you can define your own type of weaving. We will generate it and we will send all
those
the
instructions to the robot.
So it's handy because you're just doing it once and you don't, let's say you've got in your shop a few different brands of robot and you don't want to think about whether this one supports this type of functionality or not. They have covered it over here, so you don't need to worry about it at all. There's one more thing. On the production floor, by default, we install a bunch of cameras. It's nothing crazy, just a regular surveillance cameras. Why do we need that? Let's say something happened on your production floor. You don't know what to do with the robot. Something went wrong and there's an inexperienced operator came over. There's a support. In this regard, if something happens, you just text us or call us. Our guys are always on the phone and they will interact with that as soon as it could be done. But most of the scenarios we are trying to fix remotely, and it's good for us. We don't waste time coming over every specific location. But if there is a need, we're definitely coming.
How long does it take let's say your standard typical operator? How much training does he need to get up on the software?
Yeah, based on experience we have one guy on the production floor, which we are trying to teach everything. It's not only software related. Sometimes you need to know how to maintain the machine, how to change the wire, how to change contact tips, all this aspect of regular robotics. The idea is, as I showed you, there's not a lot to learn. Honestly.
It does look pretty intuitive.
We've tried to make all the software for the welder, so for him to speak with him in his language rather than a programmer. So that's why we have those work and travel angles. They are familiar with that most of the times. And let's say the welding procedures we use, they know them already. They were changing those manually in the welding source. You can do the same trick for the software and we will send this data to the welding source. So you don't need to save it anywhere else. So we will keep it all within the system.
All right. My first thought is the user interface is really nice, and that's going to be important for welders. As Timo said, it's built around how a welder would work and not around how a programmer would work. So that was my first thought, is that it's a it's a really nice system if you're not a programmer. AISC started looking at how we can automate processes probably 10, 12 years ago. And that was a question we got is, are you worried that you're taking people's jobs? And our answer was simply, even 12 years ago, is there's no one for these. We're doing the jobs that are just simply, we can't find people for. In the ensuing 10 to 12 years or so, it's not gotten better. We are taking on an initiative at AISC to address workforce development, but it's not quick. None of that is quick. It's something everyone's feeling. Automation is, it's what's going to help fill the gap right now. And we're still going to need welders, and we're still going to train welders. And we need all the technology we can to help fill the gap in the meantime. So this is going to be an ongoing issue for years. We're working on, how do we bring people into the trade? How do we bring technology into the trade? It's a multi-front battle, really.
So let's try to do one more trick.
Okay.
Do you have your phone with you?
Yes.
So let's try to place it on the way to the robot, going to the wall. Can you trust that?
I trust you, Tim Tony Stark, and I trust you. You promise?
Sure.
Sure. You said that so convincingly. Okay.
Yeah, let's try to do that. That's the phone.
Where do I put it?
Oh, let's do it like this way, next to it.
And
Let's try to do it this well, so you will place it right next to it. Let's try it.
Let's try it? Sure. So convincing. Would you put your phone in that? I am.
But it could be the case in real production, someone can just work on the part and forget the phone there, so things happening, and the system is capable to be good even though with this kind of conditions.
Great.
So right now we will see with you what we gathered from the scanning procedure.
Oh, it has the little
Those are
green
formed.
blobs.
Yeah,
Yeah.
those are features we were using on the previous run. So what we will do now, we will
And then
try
those
to...
are the seams that we're welding?
Yeah.
Okay.
So there really should be good following between those two
It
phones.
will be good.
Yeah, we will do the dry run. I don't want to damage our phones with a lot of heat coming from the welding. But besides that, it will be pretty much the same as with welding.
Okay.
Let's hope he will not crush our phones all the way through.
Stop! I've been like holding my breath.
Have you got an insurance on your phone, just in case I'm curious?
This guy, who's in comedy now? Tim. Wow. Wow. Tim, I feel like I'm ready to operate it myself. Do you trust me?
Sure, let's try it.
Let's do it. Okay, so
you got a part.
I know how to do it.
Yeah, you set up the part yourself.
My dad's a chemical engineer, so I grew up being on like the pulp and paper machines with my dad, and I would always like sit in his office in his big swivel chair, but with the back to it, and people would come in to talk to my dad, and I'd swivel around, and then they'd see like little Mary, and they're like, "Oh, you're not Bruce." I'd be like, "I'm not Bruce," but now I am an engineer. Dad,
So
love you.
now you are.
And now I am. Okay, so press and hold. Okay, it's starting.
So there's a difference the way we scan this part on this cell and on the other one. So on the first one, we were utilizing the positioner. We were moving part around and the robot was
Right,
steady.
and this is stationary.
Yes, and that's why this guy have to just run over the volume to cover
Oh,
it.
so it can get a full scan.
That's
Because it's
correct.
using its eyes to see
That's correct.
the demo. Red button,
Yep.
match. Confirm selection.
So looks pretty much like what we see with you.
Yeah,
After that, you need to press confirm
I would imagine. Mhm.
and leave the working zone of the robot.
Keep pressed for 1 second.
Yeah, press and hold the same thing. So now we can call you a certified welder with ABAGY.
Dad, are you so proud of me? That's so cool. That was so easy.
Was it difficult for you to get used to a new system you haven't seen till like a few hours ago?
Not difficult at all. What I'm really excited and inspired about is the cooperation between human and robot. So we have every idea starts with passion, right? It starts with your head and your heart, and you have a vision and you have an idea, and then it becomes a thing, like something you can touch, something you can engage with. And then with the software and everything infused together, it's so easy.
That's cool. That was our intention.
And you nailed it. A+ gold star. You should go to Fabtech and show other people about it.
Yeah.
He agrees. He went, Ksh. Yeah, good job. That was so great. So awesome. So exciting. I hope that you have enjoyed this behind the scenes tour in the demo laboratory. I hope you have learned. I hope you've been inspired. Please, in the chat, make sure you subscribe. Share with us your thoughts, your feelings, your questions, your comments. Follow ABAGY on LinkedIn. They're a very wonderful company full of very passionate, awesome people. Also Kate, who's behind the camera. They care so much, and it's so fascinating to hear the stories behind the manufacturing. Such a treat.